Hi friends, welcome to our review of 7-1, 7-2, and 7-3. This is all of our angle relationships and triangles, okay? So first of all, let's just know that angles are formed or created when two lines intersect. Okay, so this is when we're going to talk about vertical and adjacent angles when we have two lines that intersect. So remember this and this, and A, B, C, and D. And so we can talk about relationships. So remember, adjacent are angles that are right next to each other. And they share a side, one side, and the vertex. Okay, so examples of adjacent angles would be A and B, because they're right next to each other and they share a side. Angle A and angle B, or angle B and angle C, and angle C and angle D, and so on. And then we can do D and A. D and A, not DNA. I'm fine. It's been a long day. Okay. So those are adjacent angles. They just mean they're next to each other. We like to add adjacent angles because we can. The other one is the vertical angles. Okay, vertical angles are pairs of opposite angles formed by intersecting lines. So that's what's on the paper you're going to fill out. Pairs of opposite angles formed by intersecting lines. And I usually call vertical angles are opposite from each other. So vertical angles in this are angles B and D, or angles A and C. Okay, now the reason why we like vertical angles is because vertical angles are, my pencil's dying. Vertical angles are congruent. That's why we like vertical angles. So that means that we know that angle B and angle D are the same measure. Angle A and angle C are the same measure. And that's super useful when we're solving for missing angles. Okay? And then some more angle relationships. So a straight line. And notice how, B and C, or A and B, or D and C, any of these pairs, these adjacent pairs, when we're doing it this way, add up to a straight line, which is 180 degrees. Okay, and we also have a name for that, supplementary angles, if you remember that. So straight line or angles that add up to a straight line, or supplementary angles add up to 180 degrees. Okay, so most of the time you'll see supplementary angles like this, something like that. They add up to a straight line, this angle and this angle, and you're usually looking for one of them, and so you'll subtract the other one from 180 to find the missing one, right? So that works with any two angles that add up to a straight line, which are called supplementary angles. The other one on that one is complementary angles. Complementary. Add up to 90 degrees or a right angle. So that is useful. On the worksheet that you guys will be doing, it'll tell you it's 90 degrees, and then it'll be like this, and this says angle 1, and this one says angle 2, and then they tell us that angle 1, the measure of angle 1 is 42.8, and let's find the measure of angle 2 by writing an equation, and that equation just has to be 42.8 plus we don't know equals 90 degrees, because it says right there that it adds up to 90. That's your equation. Essentially, all you have to do is subtract 42.8 from 90 degrees, and we get x equals 47.2 degrees. Okay? So complementary, that's kind of example of how to do that, how to fill in when it says write an equation to find the missing things. Yeah, so there you go on that. And then the last bit is classifying triangles. So we need to remember all of our triangle stuff. So we've got names for triangles. We have to have one from each of these columns. So we're going to have acute, has all angles less than 90 degrees. And then we've got a right triangle, has one 90-degree angle, and obtuse has one obtuse angle. Okay, and then we could have scalene, which means none of the sides are the same. We can have isosceles, which means 2 of the 3 sides are the same. And then equilateral, which means all of the sides are the same. This is triangles. We moved on. Okay, so when we're naming a triangle, you need to have one name from this line and one name from this line. Okay, let's see some other stuff about triangles. Corresponding sides and angles. So we can play around. Say we have a 90-degree right triangle here, and this is A, B, and C. So remember I said that an angle corresponds with the side that it's opposite from. So angle A corresponds to side BC, and we're going to do line segment. And angle B, opposite of angle B, is line segment AC. And angle C is opposite AB. Okay, so those are your corresponding angles and sides. And then we need to remember the sum of the interior angles of a triangle is 180 degrees. So we're using that same number for our straight line and supplementary angles, 180 degrees. And so if we have 2 angle measures, we can find the third by subtracting those 2 from 180 and finding out what's missing. Okay, or we can determine whether a set of angles can make a triangle. If they add up to 180, they can. If they don't, they don't. Okay, and same thing with the sides of a triangle to determine whether or not we can have a triangle. Any 2 sides of the sum, let's add that, the sum of any 2 sides of a triangle must be greater than the third side. So if you guys remember that, like if we have 2, 10, and 3. Can we make a triangle out of those? No, because 2 plus 3 is 5. That's less than 10. That's not going to make a triangle. But if we have 2, 3, and 4, then 2 plus 4 is 6. That's bigger than 3. 3 plus 4 is bigger than 2. 2 plus 3 is 5 is bigger than 4. That works. That will make a triangle. Okay? So, that's a lot to go over pretty quickly, but there's all of our angle and triangle information.